Good morning, students. Welcome to our first class for this third term of the year 2022. Today we'll talk about tool technology. So tools is a very important element in the design and technology workshop. So without tools, the design cannot be realized. So we'll have an overview about the main hand tools used in the workshop. So as an introduction, you can follow also in your book. So tools are designed to make job easier. They are instruments or equipment used to perform operation in the realization of products. So without tools, the products cannot be realized. So what are the processes we usually do in the workshop? So all work start with the marking out. You have to mark out the required length, the required shape onto the material before cutting. So the cutting, the sewing or cutting is another process, usually done onto material. The third process is a drilling process. So we use specific tools to drill holes of different sizes into wood, metal or plastic. Another process is the planing. The planing means to level up the material. We usually use a plane, what we call a plane, to remove slices of wood or to make it flush and leveled. Then there is a joining process. So when we cut parts, we have to join them to form the required shape. And there is a finishing process. So 6 processes usually run on 2 materials. So marking out, sewing or cutting, drilling, planing, joining, and finishing. So to run these processes, we use specific tools. So tools are classified into 4 families, 4 categories. That are the marking out and measuring tools. Okay, so this is a group of tools. Another group of tools are called the driving tools. Then there are the holding tools, and finally the cutting tools. So 4 categories of tools, of hand tools. So let's have an overview about these tools. First of all, let us see the measuring and marking out tool. So during the measuring and marking out process, it's already good to have some practices, some good practices. First of all, you must avoid parallax error by placing the eye perpendicularly. So what is a parallax error? So when we measure, for example, we have one example of measurement with a ruler. If we are we place our eye in a certain direction, we can have a wrong reading. For example, when looking from this direction here, okay, the reading here is 2 centimeters. This object measured 2 centimeters, but when we read from this direction, the reading, we have a wrong reading. We read 1.9 centimeters instead of 2 centimeters. And when we look from this direction here, we have a larger reading. We read 2.4 centimeters. Okay, in fact, we should have been reading perpendicularly to the job, like here. Okay, when we read perpendicularly, we have the exact measure. So when we place our eye in a wrong position, this is called parallax error. So you should avoid parallax error when you're reading, when you're making reading onto a ruler. So this is one good practice. Then avoid end errors for accurate measurement. So what is end error? For example, when measuring, for example, this pencil, Some rulers, the zero is not at the end of the ruler. Okay, so you must make sure that you start reading from zero. Okay, and next to the required length. If you place your pencil from here, okay, you have a wrong reading. So avoid end error. Okay, for accurate measurement, another good practice. Then clamp your work securely using scrap wood. So usually when you have large pieces or even small pieces, don't clamp the work, hold it onto the workbench or somewhere to avoid it from moving while you are measuring your work. So three good practices: avoid parallax error, avoid end error, and clamp your work when measuring. So let us see some examples of measuring and marking out tools. So first of all, there is the steel rule. In the workshop, we won't be using wood or plastic rulers. We use steel rules, so to measure lengths and help to draw lines on metals, wood, and plastic. So there are different lengths of steel rule. Here we have a 30 centimeters of 300 millimeters steel rule, but it goes up to 1 meter. Okay, for small distances, we'll be using a steel rule to measure our material. Okay, it is also used to measure flatness onto materials. Okay, then we have the measuring tape. So measuring tapes are used for larger dimensions, for above 1 meters, for example. I'll be using a measuring tape. It is available in different lengths. Okay, so the measuring tape uh, is used into any material you want. Then to mark out onto the material, onto wood, we use a pencil. So to draw lines and outline shape on workpieces, on wood workpieces. So to mark position of holes, uh, we usually use a steel rule or tri-square and measuring tape. So the pencil is is an essential tool, marking tool in the workshop. So as you can see on the picture, it is used with a to mark out, to make remarks using tri-square and measuring tapes. Then on metals, we won't be using pencils on metals. We'll be using a scriber. So to draw lines and outlines, so this is scriber. So to draw lines and outline shapes on metal workpieces. This is not used on wood, but only on metals. So to mark out position of holes, to generally use with a steel rule, engineer square, and measuring tape. As you can see in the picture, the scriber has a very sharp end here and here also. Okay, so it is used to scratch the metal and to make a reading, a line or a hole onto the metal. Then if we don't want to damage our material with a scriber, we use a felt pen. It's like a marker. It's a very fine point marker. Okay, so it is used to mark out on metal and plastics. Okay, to draw lines and outline shapes on plastics, workpieces, and metals. So generally used with a ruler, engineer square, or measuring tape, or freehand marking. Okay, donc, so we use a felt pen because it does not, it doesn't erase easily, but we can remove the markings with a spirit or a solvent. So another measuring marking tools, we have what we call the tri-square. Alors, the tri-square is made up of a wooden part here. This is a wooden part which is called a stock. Okay, wooden stock. And here you have a steel blade. It has a steel blade. So this tool is used on wood and plastics. Okay, we never use a tri-square onto metals. So it is used to mark perpendicular lines, as you can see on this picture. It is used to mark perpendicular lines, okay, and to check squareness. You check squareness here. We verify if a corner is at 90 degrees. So you can use it in different position. So it is a very precise and accurate tool to mark out perpendicular lines and to check, to make sure that the edges are at 90 degrees, which is called squareness. So we have the same tool for metal readings, which we call an engineer square. Okay, as for the tri-square, it is used to draw lines at 90 degrees and workpieces, but the difference is that the blade and the stock, okay, are both in steel. They are all in metal. You have a different engineer square here. It's the same function. It's steel. All parts are made of steel, and it is used only on metals. Here, this one is used to measure only 90 degrees, but this one is used to measure also at 45 degrees. As you can see here, you can mark out lines at 45 degrees and or at 90 degrees. So here you can check squareness onto the onto materials to see if the corner is well cut at 90 degrees. So the engineer square is used on metals and plastics also, but never onto wood. So we have another tool which is called a sliding bevel, which have the same function as the tri-square and engineer square. So this one, it helps draw lines at angles on wood, metals, or plastic workpieces. So as the tri-square and engineer square, it is used to mark angles, but it has an adjustable blade. So this blade, an adjustable blade. Sorry. It has an adjustable blade which can be adjusted at any angle we want. Okay, as you can see here, the blade are adjusted at any angle you want, so you can draw perpendicular lines, parallel lines at any angle. So it can be used onto metal, plastics, or wood. Okay, if you have angles other than 90 degrees or 45 degrees to draw. So then another measuring tool is called an external caliper. So here you have two models of external caliper. You have one at the left here, which has is very precise, okay, and another one on the right, which is frequently used also. They are external caliper. So they are used to measure external dimensions onto bars, tubes, and generally we use with a steel ruler. So the readings here, for example, as you can see below here, so we measure the thicknesses of objects, and then you put it into a ruler to read the measurement. For example, the tube here, the tube is measured, the external dimension or measured using an external caliper. Then the reading is put into a ruler to see how much is the diameter. So this is an external caliper. So you have also to measure inner dimensions, we have an internal caliper. So to measure internal dimensions of tubes, generally use a steel ruler. So this is an internal caliper. So that, as you can see, some tubes have a thickness. So the external diameter and the internal diameter are not the same. So to measure the inside diameter, we use an internal caliper. So the shape has a very distorted end, which can be used to measure the internal diameter of objects. Then we have another caliper, which we will see this caliper next time. We'll be seeing that the compass now. It's a marking tool, the pencil compass, as you use in the on paper. The same compass is used in the workshop to mark out onto wood. Okay, it is used to draw arcs and circles onto workpieces, wooden workpieces mainly. So, which is very frequently used onto wood in the workshop. But if you have to draw onto metals, we won't be using a pencil compass, we'll be using a divider. So to draw arcs and circles onto metal pieces and to transfer measurement, we use a divider. So this is a divider. It has two sharp ends. Instead of pencil, it has two sharp ends here and here, which are used to scratch the metal materials. Okay, so it is not used onto wood because it will damage the wood. Then we have also the marking gauge. So this tool is used to mark lines parallel to the edge of wood workpieces. As you can see on this drawing here, here you have a sharp tip here, which is used to scratch and mark out the wood. As you can see here, when you rub the marking gauge on one edge, okay, it will make a parallel line to the edge. So it scratches the wood and make a parallel line to the edge. The picture also here, you can see the scratch here. So it is used to mark lines parallel to one edge onto wood only. Okay, so this part is a moving part, which is called the stock. Okay, and this part is called the stem, and this part is called the spur. Okay, and this is the marking part. So the marking gauge is used to mark parallel lines onto wood work pieces. So you have another instrument which has the same function but onto metals, which is called the odd leg caliper. So to mark lines parallel to one edge onto metal workpieces, we use an odd leg caliper. So this is an odd leg caliper. It looks like a divider, but it has only one edge, which is very sharp. The other part, this is called the dog leg part. Okay, so this part is like a hook. For example, here you can see it here, and you pass it onto the one edge, and it makes a parallel line to one edge. This is an odd leg caliper used to mark parallel lines onto metals. So another marking tool is the center punch. Okay, so the center punch is like a big nail. Okay, it is used to make an indentation on metals. Okay, so before you drill using a twist drill to drill a hole, you make an indentation to make sure that the drill does not slip onto the material, onto the metal material. So with a hammer, you place the center punch onto the center of the hole you have to drill, and you make a small indentation, okay, with a small strike. You make an indentation to make a small hole. So this the center punch is used to make this hole before drilling. Okay, so this is a mark, it marks centers before drilling onto metals only, not on, we don't use it on wood or plastic. So there is another tool which resembles a center punch, but it is called a dot punch. So the dot punch, here it is, it scribe lines on metal workpieces before folding. When you have a sheet of metal we want to fold, okay, so uh, the 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 dot punch is used to make small holes. As you can see here, there are dots here. There are dots made by the dot punch, okay, with a hammer, and then you can fold the sheet easier when the dots are made. You have to just fold the sheet; it will fold on the dots. So the dot punch is used for that purpose, to make small indentation onto sheets of metal before shaping. So then we have another categories of tools which is are called holding tools. Okay, the holding tools are used to clamp materials firmly during different operations such as cutting and joining operation. So there are some common holding tools. Okay, uh, so good practices when using holding tools. So you use a scrap material between the jaws and the material so as to protect the surface of the workpiece. So the first one example of the holding tool is the bench vise. So to hold wood workpieces for sewing, chiseling, and planing, we use the bench vise. So this is only for wood purposes. So as you can see, the bench vise is fixed onto the workbench, okay, and then you use a scrap material. So this is a scrap material between the jaws and the material itself, not to damage the material when you squeeze the workpiece in the workbench. So then you can plane easily without damaging your work. So this is an important tool for woodworking. Okay. For metal, we have the same a similar tool, which is called an engineer's vise. Okay, to hold metal workpieces for cutting, filing, and bending. So this is an engineer's vise. So this holding tool is for metals and hard plastics. The difference is that there are the jaws here has some grips here, just has it exerts higher pressure to the material. So if you put wood inside it, it will crush the wood. So we use it only onto metals or plastic. Okay, so an engineer's vise for metal. Then we have the G clamp. So it is called a G clamp because it has a G shape. Okay, to hold, it is used on wood, metals, and plastics. So it hold workpieces on the bench for cutting and joining. So even when you're gluing wood together, you can use G-clamp to hold them together while they are setting up. So this is a G-clamp. There are different sizes of G-clamp um, for wood, metals, or plastics. Then you have the sash clamp. So the sash clamp, it's like a G clamp, but it is very long. It is up to 1 meters to 2 meters. You can have sash clamp of 2 meters also. So to hold large workpieces during joining operation. For example, when you're making a frame, a door frame or a table, you will be needing a large holding device. So the sash clamp is used for that purpose, as you can see on the picture. So this is a moving part. This is the moving part which slides along the rod, and which you can it is appropriate for large surfaces. Then you have the corner clamp. So the corner clamp, sorry, it's not the F clamp. It's a wrong reading. It's a corner clamp. Okay, so it is used to hold workpieces at right angle. So it's at 90 degrees. As you can see on this picture, the workpieces are held at 90 degrees. So automatically set at 90 degrees when you're joining the workpieces. You don't have to use a tri-square to measure. It is already at 90 degrees. So this is called a corner clamp. Then another holding tool is called the bench hook. So the bench hook is made of wood generally. So it has the two sides are the same. Okay, you clip it on your workbench, and you can use it as a holding tool when you're cutting workpieces, as you can see on the picture. So you clip it on the workbench here, and you push your workpiece with this stock here, and you can cut easily. So the bench hook, to hold workpieces while sewing and chiseling, it can also be used in a bench vise. So then you have the miter box. So the miter box is used to hold workpieces when cutting at 45 degrees. So in the miter box, we have slots, as you can see here. There are slots cut at 45 degrees. So you just have to fit your saw in the slot, and automatically when you're sewing, it will sew at 45 degrees in either direction. So you don't have to measure. You just slide your workpiece in the slot, your saw in the slot, and it will cut at 45 degrees. So this is a miter box. Then another holding tool are called pliers. So they are used to hold and grip small workpieces, and they are available in different sizes and shapes, as you can see on this picture. So the pliers, there are different sizes, needle shape pliers, round shape pliers, and square shape pliers. So they are used to hold small objects. For example, for when cutting or when welding or when screwing. So this is a very important holding tool. So here you are for this first part. So we have seen measuring and marking out tools, then holding tools. For the next part, we'll be seeing cutting and drilling tools. Till then, keep safe.